classes or class. And then this column will be frequency, number of occurrence, frequency. This column, I want to make this column relative frequency. Relative frequency. Okay, so for now, that's what I want to do. All right, so look at, I say because I want to build 4 classes and the class width is going to be 2. How do I know that? Range divided by the number of classes. So I'm going to start from 0 is the smallest number. 0 plus 2 is 2. 2 plus 2 is 4. 4 plus 2 is 6. So I want to have 4 classes, and that's all that I have. I created the lower limit. So the upper limit is going to be 0 to 1, because if this is 2, the upper limit of the first class has to be 1. 2 to 3. Why 3? Because the upper limit of this class must be 1 lower than 4 to 5, then 6 to 7. So there goes my 4 classes. I already knew I want to make 4 classes. So that is why I divided the range by 4. And then the range is 7 divided by 4 is 2 approximately, because I cannot use, I'm not allowed to use a fractional class width. So the class width is 2. In other words, the distance between consecutive lower limits is 2. Okay, so now I want to find the frequency. From 0 to 1, how many numbers range from 0 to 1? Remember when you were in middle school, you knew how to tally. So I'm going to tally. How many numbers range from 0 to 1? So I have this is 1. So I can count them. So let me count. So 1, let me get my, okay. So I got that. Okay, now I want to count. So how many numbers range from 0 to 1? So in other words, what is the frequency of the first class? Those 2 numbers are between 0 and 1. So 1, 2. None of the numbers is between 0 and 1. So 1, 2, 3, 4, 5. Therefore, the frequency of the first class is 5. The frequency of the first class is 5. So I'll come over here and write 5. Frequency of the first class is 5. In other words, all the numbers ranging from 0 to 1, the total number of them is 5. Okay, the next one is find all the numbers in the second class. That means all the numbers ranging from 2 to 3. All right, so let me do that. I have 1, 2 to 3. I have 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 10, 11. There are 11 numbers ranging from 2 to 3, so I put 11 here. In other words, the relative frequency of the frequency of numbers 2 to 3 is 11. We can count again. For numbers ranging from 2 to 3, if I count them, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 of them. We did right. So the next class is 4 to 5. How many to get there? 2, 5. I have 1, 2, 3. That's it. So all the numbers ranging from 4 to 5. There are only 3 of them. Okay, for the last class, I'm going to be looking for numbers ranging from 6 to 7. There is none in this column, none here, none here, none here. One number is between 6 and 7. All right, so altogether 1. Okay, so there is only 1 here. So what I'm going to do quickly is find the total frequency. How many, what is the count of all the digits? Notice that all those digits are discrete. There is no fraction. So let's count. The number of classes or numbers, I mean, the number of frequencies, so I'm going to count them. What is the frequency? 5 plus 11 is 16. 16 plus 3 is 19 plus 1 is 20. So the total frequency is 20 according to my frequency distribution. But let me go back and check. Is it true? I can check my answer and make sure it is 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, good. So total frequency is correct. Now, because I know the total frequency, I can find the relative frequency. The relative frequency is always the frequency of class over the total frequency. Frequency of class over total frequency. So for the first class, the relative frequency is 5 out of 20. For the second class, the relative frequency is 11 out of 20. For the third class, the relative frequency is 3 out of 20. For the fourth class, the relative frequency is 1 out of 20. I don't really have to write them in fractions. I can leave it like this. But if you want to, you can put them in fractions. Okay, so suppose I'm also supposed to, suppose I am told to create a column for cumulative relative frequency. I could be told to create a column for cumulative relative frequency. So the cumulative relative frequency, if you want to find that, it is, you accumulate the frequencies from, so let's accumulate the frequency. From the first class, there is no other frequency. 5 over 20 relative frequency for the first class is the same as the relative frequency of the class. For the second class, is the frequency of the first frequency of the second class. So the first class plus the going to give me 16 out of 20. The cumulative relative frequency of the third class is 19 out of 20. The cumulative out of 20. Okay, so you see that the cumulative relative frequency of the last class is actually 1. Very soon we shall emphasize this one. So this is 1. Okay, so I have created, this table is called the frequency table. Actually, the first 2 columns is called the frequency distribution table. And in the frequency distribution table, we included the relative frequency and cumulative relative frequency. We can also include other columns. Let me include another column. That's another column we can include here. And I can call this column the class midpoint. Class midpoint. So the class midpoint, is lower limit plus upper limit divided by 2. Lower limit plus upper limit divided by 2. So 0 plus 1 divided by 2. So the class midpoint of the first class is 1/2. I can put 1/2 here, or 0.5. The class midpoint of the second class is 2 plus 3, lower limit plus upper limit divided by 2. And that's going to give me 5. 5 divided by 2 is 2.5 or 2.5. But I'm going to write 5/2. 5/2. Well, if I keep on going, I will notice that the class width differ by 2. Why? Because the class midpoint differ by 2. So the class width here is 2. The difference between consecutive lower limits. So all I have to do is keep on adding 2 here. So right here, I am going to have a 9/2. 9/2. And if I'm going to add 4 here, so I have 13/2. So I found the class midpoints, and I found almost everything I need. Suppose I'm told to find the class width. I already said it. The class width is the difference between consecutive lower limits or the difference between consecutive upper limits. So that's the class width. So the first thing we wanted to do this morning is to construct a frequency distribution table. We could also be told to find the, put all these numbers in a calculator and find the mean, find the 5-number summary, and so on. Okay, so that is the first thing we want to do, to make a frequency distribution table. Okay, remember at the beginning, we found the minimum number and the maximum number. Step 2, find the range. The range is maximum minus minimum. Step 3, find the number of classes you want to have. I wanted to have 4 classes. So divide the range by the number of classes you want to have. I did. 7 divided by 4 is 3/4, or approximately 2, because that is actually the class width. It's not supposed to be a fraction. Okay, now create your classes. I like to start by creating all the lower limits. Start from the minimum number. So 0 is the minimum number. And I keep adding the class width. And then when I finish, I will create the upper class, upper limits. And the upper limits must be, the upper limit here is 1, right here is 2. It has to be 1 lower than the next consecutive lower limit. So that is how we, and then after you finish, you have created the classes. From the classes, you check the data you are given. From there, you create the frequencies. Okay, and when you finish creating the frequencies, you find the total frequency. Make sure that the total frequency is equal to the count of the data given to you. Okay, when you're done, you go to create the relative frequency if you're told to create the relative frequency. The relative frequency is the frequency of class divided by the total frequency. And you already know the frequency of the first class is 5 divided by total frequency. Therefore, the relative frequency of the first class is 5 out of 20. The relative frequency of the second class is 11 out of 20. The relative frequency of the third class is 3 out of 20, 1 out of 20. So you have created the column for relative frequency. You can also be told to create a column for cumulative relative frequency. So you see, for the first class, there is no other class above the first class. So the cumulative relative frequency of the first class is 5 out of 20. But the cumulative relative frequency of the second class is the relative frequency of the second class plus the relative frequency of the first class. So that's why I have 16 here. The cumulative relative frequency of the third class is the relative frequency of the third class plus the relative frequency of the second class plus the relative frequency of the first class. And so I have 19 out of 20. The cumulative relative frequency of the fourth class, which is the last class, must be equal to 1. Must be equal to 1. In other words, you add up all the relative frequencies and your answer is going to be 20 over 20 because the total frequency is 20. And so that is how to create the cumulative relative frequency. You can also be told to create the class midpoint. So the class midpoint is always the lower limit of each class plus the upper limit of the same class divided by 2. For example, for the class midpoint of the first class, I did the lower limit of the first class plus the upper limit of the first class divided by 2. So that is how I have 1/2 here. So I came over here and wrote 1/2. And so on. All right, so right now we have created the classes frequency distribution table. There we have classes, we have frequency, we have relative frequency, we have cumulative relative frequency, we have class midpoint, depending on what you're told to do. All right. So the next thing we want to do, let me go back to chapter 2. So here, remember we are working on chapter 2. So constructing and organizing discrete said that discrete means that there is no decimal. See, there's no decimal right there. Okay, so we have the next one is to do a histogram. Draw a histogram. So I want to draw a histogram. I'm going to actually get the data I just used. I'm going to get that data and then draw a histogram. So I'm going to use this to draw a histogram. I'm going to clean the other side. So I can draw a histogram of this data. So I am drawing a histogram of the data. So the first thing I want to do, I want to draw a histogram. This is just a rough sketch. So classes will be on the horizontal level, classes. Okay, so I have let me just put in. So I have 4 classes. So I can put the classes here from 0 to 1, 2 to 3, 4 to 5, and 6 to 7. Alternatively, I can use class midpoints. The maximum frequency is actually, if I look at this, I know that the highest frequency for the class is 11. So I can say 2, 4, 6, 8, 10, 12. Because the highest frequency for the class is 11, I decided to use intervals of 2. Okay, now I want class. So frequency of the first class is 5. So that is the estimate, and I will share the bar. So that is the bar for the first class. For the second class, 2 to 5, the frequency is 11. So you see, this is where 11 is. I'm going to draw a line. Uh-oh. Now I am going to draw a line and make a rough sketch. So that is the bar for the second class. Now the third class has a frequency of 3. So 3 is somewhere here. And that is the bar. Remember, I have 4 classes. Therefore, I will have I have 4 bars. For the last class, 6 to 7, the frequency is 1. So this is approximately. So this is frequency histogram. Frequency histogram. So if I'm told to draw a frequency histogram, I am going to draw a frequency histogram. So this is frequency histogram. What if I'm told to draw a relative frequency histogram? What if the question says draw a relative frequency histogram? Actually, I can leave my, I can just go to my right-hand side and rewrite what I just did. So the most important thing is that I can just go ahead and put the denominator. So here I have, I had 2 here, so 2 out of 20, 4 out of 20, because it's relative frequency this time. So I'm changing the y-axis to relative frequency. I'm changing the y-axis to relative frequency. So remember I said, what if I am told to draw a relative frequency histogram? So that becomes a relative frequency histogram. Okay, also, I could be told to draw a relative frequency polygon inside my graph, relative frequency polygon. Remember when you were in doing geometry, remember that a polygon is a closed figure bounded by line segments. So some questions can tell you to draw a relative frequency polygon, but don't forget your geometry. It says that a polygon is a plane figure bounded by line segments. But if you already have a relative frequency histogram and you are told to draw a relative frequency polygon, mark the centers of your histogram and connect them. So now I connect them, connect this one, connect the points you marked. So I connect the points I marked. And then this black line is the relative frequency polygon, relative frequency polygon. So you could be told to draw a relative frequency polygon inside your relative frequency histogram. Also, the next thing will be find the 5-number summary find the quartiles. See, that we already talked about that yesterday. I mean, the other day, last week. You could be told to find the mean, find the 5-number summary. You could be told to find the mode and find the interquartile range. So it's a raw data. The first thing you want to do is key in the data in your key the data in. So I am going to clear L1 and I'm using the raw data right now. I'm using the raw data. So I'm told to find the 5-number summary. So I have put the data in right now. 5, 2, 1, 1, 3, 4. I mean column 3, column 4, 3, 4, column 5, 2, 7, column 6, 3, 0, column 8, 2, 2, column 9, 1, 1. Okay, let me go to the last number. The next one is 2, 2, 2, 2. I already know that there are the total frequency is 20. So if my calculator is asking me for the next number, give me the next number, then I know there are 20 of them. So we have the right number. Also, I want to take away I want to go to the mode and make sure that it's some float. So the mode is some float. All right, so the next thing I want to do now, and I want to also make sure that it is real. I'm not calculating numbers that are complex. Okay, so now I will second quit. Remember, I am told to calculate the mean or decide whether the data is skewed. So I want to calculate the one variable stat so that I can find the mean and the median, find which one is greater. I can make a decision from there. So I go to stat, one variable stat, and I'm doing one variable stat of the data in L1. Okay, so I'm using the raw data because I know the raw data. If I don't have the raw data, then I could have used the group data, but I know the raw data. Do you have frequency column? No. So I'm going to calculate. So it tells me that the mean of this data is 2.5. So I'm going to I'm pulling up my whiteboard again, and I'm going to clean up my whiteboard so I can have a space to. So I'm going to clean that whiteboard. I found the mean. The mean of the data is 2.45. Therefore, the mean is 2.45. And this data, I'm not told whether it's population or sample. So I'm going to assume it's sample. 2.45 is the mean. And I only need the mean and the median. So I'm going to arrow down and look for the median. Second quartile is the median. I'm going to arrow down. Second quartile is 2. That is the median. So Q2, second quartile, is 2. So now I can make the decision. Is this data skewed? Yes, it is skewed right. Why do I say that? The data is skewed right because the mean is greater than the median. The data is skewed right because the mean is greater than the median. So this is X bar, 2.45, the median, Q2, second quartile. Therefore, the data is skewed right. So remember, I'm told to make a decision about the skewness of the data. Is this skewed? Yes, it's skewed right. So the mean is 2.45. The median is 2. I could also be told to find the interquartile range. Remember the other day we talked about interquartile range. The interquartile range is Q3 minus Q1. So let's go ahead and find the interquartile range, IQR. So if I'm looking at my calculator again, I see that the interquartile range is Q3 is 3, Q1 is 1.5, 3 minus 1.5 is 1.5. Therefore, IQR is 1.5. The interquartile range is 1.5. I could be told to find so many things using one data. So I found the interquartile range. I could be told to draw a histogram. If I'm told to draw a histogram of this data in my calculator, let me go ahead and draw a histogram. I already have a lot of information about this data. So let me draw a histogram of this data. Remember, the graphs of any statistical graph is in stat plot. So how do I access the stat plot? I'll go to second stat plot. I like to take plot 1. And I'm told to draw a histogram. Look at the number of plots that I have. So I can have 6 plots. The first one is the scatter plot. Second one is maybe the ogive, the line graph. The third one is histogram. That's what I'm told to do. Let's look at the fourth one. The fourth one is a modified box plot used to see if an outlier is in the data. The fifth plot is an ordinary box plot. The sixth one is a quantile plot. It's also used to check if a data is normally distributed. Okay, so I'm going to go back and choose, I'll go back and choose histogram because that's what I'm doing. So I'll select histogram. And then it's going to ask me in which list is the data. My list is in L1. I don't have a frequency list, so I just do alpha 1 there. Alpha 1, no frequency list. I want to make sure that I draw the statistical plot when the frequency is 1 because it's a raw data. It's a raw data. So let me sketch the histogram. So I'm going to sketch this. How do I do this? I want you to know that whenever you are sketching a statistical plot, you do zoom 9. Zoom. Why do we do zoom 9? If I do zoom 9, it means that I'm drawing a statistical plot. Note that is zoom 9 means zoom statistic. Zoom 9. So I select that. And so this is what I have. I'm going to count the bars. 1, 2, 3, 4. So it's more than 4. So this is not actually, I had 4 classes. So I want to fix this histogram so it will look like the classes that I have. How do I check it? How do I fix it? I already know that I decided to have a class width of 2. So I'm going to go to Windows and make sure I put an X scale of 2. So class width in this is 2. And for now, I think I'm okay with 2. I can now, after zooming 9, I don't have to zoom 9 again. So I'm just going to push graph. So now I have 4 bars. So this is now looking like the graph that I have here, and so on. So I can be told to draw a frequency histogram using my calculator or by hand. I did it by hand and I did it by calculator. So you feel free to do it any way you like. But you need to know how to do it both, maybe by hand. Okay. We have already calculated the interquartile range. We know the quartiles. We know the range. We know the maximum number. So we have, let me see if you have any question, by the way. Let me see. Let's see. Do you have any question? Anybody has any question? I'm recording this, by the way, so that way I'm recording this so that if anybody comes in late. Nehemiah, do you have any question? Do you have any question? All right, I can continue. So we started by working on a group data. So we grouped a discrete data. We grouped a discrete data. So this is how to work with a group data. So the next down, let's go down. By the way, test is where so today we are doing frequency distribution, histogram. We are given classes on the, if you look at, by the way, I'm going to clean this, that way I can use the space to answer the question. So I'm given a frequency distribution table. Actually, I am given a histogram. So I am told to create, see if I can recoup some of the data. It's already created. So they didn't give me the raw data. I want to see how much of the original data I can create from here. So I given this data, the first thing I want to do is to make a frequency distribution table containing only the classes and the frequency. So let me do that. So, so I'm trying to create a frequency distribution table of this data here. And here I have the frequency. The first class is 56 to, look at the first class right here. First class is 56 to 58. So I have 56 to 58. The second class is 59 to 61. The third class is 62 to 64. The fourth class is 65. You are low on disk space. Wow. Storage sense. Okay. Okay, so 62 to 65 is the 64. The next class is 65 to 67. 65 to 67. The next class is 68 to 70. 68 to 70. So 68 to 70. 68 to 70. And the next class is, and I'm going to minimize this one, that way I can see. Okay. All right. So now the next 68 to 70, the next class is 71 to 73. So 71 to 73. All right. Remember what I'm told to do. I'm told to, this frequency, they did this histogram, they did not give me the original data. They want me to recoup as much as I can, because as soon as they finish This is the class here. This is frequency. As soon as you finish and throw away the original data, you may not be able to recoup the original data. So I'm going to go back to the data and see how much of the, okay. So looking at this data given to me, if I look here, I see that at the y-axis, I see that the first class has 5. We are reading this, the scales on the left-hand side. So the first class has frequency of 5. Look at the second class. Second class has frequency of 20. So this is frequency of 5, frequency of 20. So I'll go back again. The third class has a frequency of 35. The fourth class has frequency of 40, 35, 40. The fourth class, actually, the next class has frequency of 25, and the last class has frequency of 10. So this is 25, this is 10. Okay, so I am creating the frequency of the histogram given to me. So let me add, by the way, so these are number of students. Let's look at the question again. So this use the histogram to determine the probability that a student chosen at random from this school will be 59 to 69 inches tall. Round the probability to the nearest tenth of percent. I want you to know that probability is the same as relative frequency. So we shall call it relative frequency. Find the relative frequency that a student is in the class 59 to 61. Find the relative frequency. So it means we have to find the relative frequency of all the. So right now I am going to find the relative frequency of all the classes. But before I find the relative frequency of all the classes, I need to know the total frequency. So what is the total frequency? How many students were included? So I can actually go ahead and add them up. So I have 5 plus 20, 5 plus 20, plus 35, plus 40, plus 25, plus 10. So I want to check that I have 35, 40, 25, 10. And if I hit enter, I have 135. So there are 135 students altogether. 135. Now I am going to create a column for relative frequency. Relative frequency is the same, relative frequency is the same as probability. So because they asked us what is the probability. It is the frequency of class over total. Frequency of class over total. And we are only interested in the relative frequency of the second class. So it is 20 over 135. And we are told to leave an answer in percent. Let's look at that question again. We are told to leave an answer in percent because it says around the probability to the nearest tenth of a percent. Okay, so all I have to do is put that in my calculator, and 20 over 135 multiplied by 100, 20 divided by 135, and my answer is that multiply by 100, I have 14.8 approximately, because the question said leave your answer to the nearest tenth. So according to my calculator, the probability that a student is in the second class is 14.8%. The probability that a student is in the second class is 14.8%. All right, I'm going to stop the class here so that I can entertain questions. I want to see if anybody has a question. It is 10:53 right now. So I want to see if anyone has a question. Okay, so today, in summary, we found we talked about a grouped data. So we're given a raw data, we grouped it into frequency distribution table. And from there, we calculated the relative frequency, which is frequency of class over total. And then we also calculated the cumulative relative frequency. We checked to see if the data is skewed right or skewed left. We remember that when data is skewed right, the mean is greater than the median. The data is skewed left, mean is less than the median. And then we calculated the class midpoint. The class midpoint is lower limit plus upper limit divided by 2. We did that. We know that the class width, by the way, the class width for this table right here, if I'm told to calculate the class width, it is the distance between consecutive lower limits. 53 minus 56 is 3. So class width is 3 for this. 65 minus 62 is 3. Therefore, the class width in this table here is 3. 68 minus 65 is 3. 71 minus 68 is 3. So the class weight. So you could be told to calculate the class weight. The class weight or class size is the difference between consecutive lower limits or difference between consecutive upper limits.